Entity Framework Core does a pretty good job of protecting us from things like SQL injection attacks, but there are still some cases that we need to be very careful about. Let's mash on that.
Hi everybody, and welcome to another episode of the Asp.Net Monsters. Today's episode is brought to you by AppFair, continuous integration services for Windows developers. So today we're going to talk about SQL injection. Is this
a
blast from the past?
A blast
Are we
from the
writing
past.
PHP here? Is it even worse than that? Are we writing Razor pages?
Well, that's a topic for another episode, Simon. No, this is actually probably the first in a series here where we're going to start diving into new features in Entity Framework Core 2. And there's one that kind of jumped out at me right away. Actually, we're going to do a number of episodes just on new features in .NET Core 2 and ASP.NET Core 2. But today we're talking about Entity Framework, and there's one feature down here in this announcement that kind of piqued my interest. And look, there's one thing that kind of bothered me about it, or that at least we need to be really careful about. So they added this feature called string interpolation from FromSql. So FromSql is a feature that lets you query for a set of entities, and you just give it the SQL that you want to use to do that. Now,
okay, so this would be for like scenarios where you have stuff that crosses between bounded contexts, or stuff where you needed to like hand tune the SQL a little bit.
Yeah, or maybe you just have like a report type entity and you're getting data from a bunch of different places, but you don't really need to, you just need to query it easily. You still want it in an entity though.
Okay.
It's a flexible way to query for your data without using the queries that are just generated for you by SQL. So one thing that you need to be careful about always when you're talking about writing your own SQL and running that against your database, especially if it involves any kind of user inputs, like if they're searching by name, for example, is you need to make sure that you're parameterizing those values that you're passing in for your query to make sure that it's executed in a safe way and that somebody can't just drop a table from your database or inject some kind of attack or query data that they're not supposed to see. And I'll show an example of that here in our app. What they've done is they've added an easy way to use C# string interpolation and do that in a safe manner. So I see this often where people they use string interpolation. So city and contact title here are two variables that we need to pass into the query. We want to use them in our where clause. And people use string interpolation like this to build up the SQL query, which is potentially dangerous. That's where the SQL injection can come and play. But what they've done here is that they're kind of intercepting that at this point with the string interpolation using a special overload of FromSql. So they know that it's an interpolated string, and then they're creating parameters and actually parameterizing those two values. So let's just, I have a sample app here and we'll just kind of walk through that. So they show the SQL that gets generated from that and how it's safe. There's one thing I don't like about this, and that I think it's potentially a path for people to accidentally introduce SQL injection attacks, and I'll show you why I think that is. So let's just have a look at our example. Little break from our usual examples. We're in Visual Studio Code today. Just did a console app this time. We don't need a whole web application to show this. So I just did a .NET new console app and added Entity Framework Core and Entity Framework Core SQL Server. I actually only really need that second one because it transitively adds the Entity Framework Core package. And then all my app is a single program CS with a few classes in it. So I have an employee class. That's the thing that we're going to query for. It has an ID, a first name, and a last name, just really simple. And a DB context here that has a DB set of employees. And in my onConfiguring method, I'm doing two things. Not using a configuration file or anything here, just for the sample. I'm specifying the connection string, so I'm connecting to my local DB database named employee data. And then I'm setting up a custom logger here to log out to the console any of my database commands. And that's so that we can see the queries that are executed here. So now in my main app, when I run the app, I start out by creating a context, and I drop my database and recreate it just for the purposes of this demo. I create a few different people in my app. David Paquette, Simon Tibbs, and James Chambers, and then another random David, because you always need at least 2 Davids in your examples, or any company I've ever worked at. Right, Mr. Tibbs?
Yeah, I've certainly seen a bunch of naming conflicts with the name David. Funnily enough, I don't know a whole lot of other Tibbs.
No, you're the only one.
Yeah.
Only one I know. And then I query. So here we're doing kind of the unsafe approach, because I wanted to show, I think we talked about SQL injection attacks, or it's something that maybe we used to talk about a long time ago. You mentioned this was a bit of a blast from the past when I brought up the topic, Simon, and maybe people haven't kind of seen it in action, so I wanted to show an example of SQL injection. So
how is this interesting? I was talking to somebody about SQL the other day, and they were saying that when they're testing their juniors coming in, like new employees, they don't even ask them about SQL anymore, because there's a whole generation of people who have been brought up on things like Active Record and Entity Framework, and they don't know that SQL exists.
Really?
Or they just have like no idea about it, so they stopped asking people questions about it. So I think it's really interesting, and
that is
so this
interesting.
is probably a good thing for us to talk about.
Yeah, that maybe even makes this more problematic when we get to showing how easy it is to go from that interpolated string to accidentally introducing a SQL injection attack. So let's just start with this example. So imagine that search string is something that is passed in that the user entered. They're doing a search for employees here. So I'm saying, give me a set of employees from SQL. I'm just doing select star from employees, where the first name equals, and then in single quotes, my search string. And then I output all the last names. So I should get Paquette and Smith here when I run this. And I'll just show you that this database does in fact exist. So this is connected to my local DB here, where I was. That's interesting. I may need to reconnect. Expanding my list of databases. There's my employee data with my table employees in it. And there's my 4 employees that I had added. If we switch back to my application, we can see there's Paquette and Smith that was output. And there's my, where's my, right here, select star from employees where first name is David. So let's take a look at how SQL injection works here. The idea is that somebody could be clever about the value that they enter for the search string here and kind of terminate this select statement and then start adding things that they shouldn't be adding. So what I could do as a clever attacker here is I could terminate that string. So I'm done with the where clause now. I've searched for David, and then I could do something like drop table employees. And then how do I do, is it dash dash for
dash dash?
Yeah. For a comment, which will then basically tell it to ignore the terminating string at the end. So now when I run this, it should delete my employees table, which would be a really bad thing if that were to happen in real life. See if I got this right. My sample is a bit slow to run just because I'm doing that drop database and recreate database.
Right. Okay.
But okay, so it appears to have run properly. It returned my Paquette and Smith because it did the select like you would have expected, but there's my drop table employees. Now if we switch back here and I refresh my list of tables, you'll see that that employees table is gone. Now all the data in my database is gone.
Unfortunate.
So that sucks. That's something you have to be careful about. Now there's easy ways to not do that. What we can do, if we were to do the FromSql with kind of a proper parameterization here, it would be, there's a way to just pass in the parameters. So I would say search string, and I believe it's, now this is where I always get confused between the two versions, 0. So I would do this, This is in Entity Framework Core version 1. This is how I would do a parameterized query. So now if I do this, it shouldn't drop my table anymore. What it's going to do is search for first names that match all of this, which is going to be nothing. So when I run this now, I should get nothing as my output. And my query should be parameterized properly, and my data should still exist at the end of the sample.
Okay.
Fingers crossed. So there's my parameterized query.
Right, okay. And we didn't get anything back. So
we didn't get anything back, so that's kind of what we expected, right? And if we refresh, there's my employees table. And if we look at the data, it's all there. So that's good. That's better.
Okay.
That's typically what you want to do. Now, if we start looking at how they've approached this with the string interpolation, if I were to do, let's just do this. So now I'm using that fancy C# feature and referencing the string this way, and I'm not passing it in here anymore. This should parameterize the query just like it did in the last example, which is a good thing. That's what we want.
I'm really interested. I'm going to have to see how they implemented this, because I was always under the impression that like interpolated strings were basically like you couldn't tell any difference from them from regular strings.
So you'll probably see as soon as I go to the next step here how they did it exactly. Select star from employees where first name is at P0, so that's good. That's what we wanted. And I should have changed this back to this, but that's safe from a SQL injection attack now because it's parameterized. The problem I have with that, though, is that I feel like this is a path for somebody to very easily accidentally add a SQL injection attack. So if I hover over this right now, I should see, will it tell me which one it uses? Okay, so you'll see that it's using the overload from SQL. At the bottom there it says formatable string SQL. So there's some interesting things that are happening there, I think, with the, I don't know if it's at runtime or with the compiler. I haven't looked at it very closely, but when you do that, the string interpolation, that's a formatable string. And there's an implicit, I think, conversion between a formatable string to a string that uses string.format.
Right, so
that
I think
makes sense
if
to
you
you.
would, like,
so this
take a
is
look
where
at
it's dangerous. If I go, sorry, go ahead.
Yeah, so I think if you look at the IL that gets built from this, then it basically maps down to like a string.format.
Right.
So maybe that returns a formatable string.
Oh, maybe. That'll be something to look at.
Yeah.
And then the toString method to that just applies the format. That would make sense. So let's say somebody comes in here and they want to do some refactoring because they don't like the way that's written. They wanted to extract that SQL. So they did that here. They did var SQL equals this. And then they go to run it. So now that's a string. SQL is a string. And we're passing a string. We're not using the right overload anymore. So I go to run this, and it's going to give me an error because that's going to be invalid SQL. It's going to be looking for basically a column name named David that it can't find because it's not wrapped with quotation marks to indicate that it's a string. So there's my error saying invalid column name David. So what I'm worried about is that somebody comes along here and says, oh, well, that's just not the way that's supposed to look, and they add the quotes in and hit run. Everything runs properly. Maybe they're not super familiar with the problem of SQL injection attacks, and now they've accidentally introduced one. So that worked. We got our data back. The query ran, but you'll see that it's no longer a parameterized query just by moving it out and adding some quotes. So in this case, you had to modify the SQL to introduce that attack. But there are other scenarios, and it's actually Nick Craver. he was chatting about it on Twitter, and he posted some examples up on GitHub, which I'll link to here. So he has kind of some queries where you don't even have to introduce a change to it. All you did was extracted a variable, and it's no longer a parameterized query. And I don't think that's something that people will necessarily expect.
Yeah, I don't think so either. I don't think any like refactoring tools would point that out either. Like you just go and you select a string and you go, I want to parameterize this, or I want to extract this string, and in 99% of cases, I would argue every case that I've ever seen other than this one, that continues to work as expected.
So it changes the behavior pretty substantially and it's such a subtle change that I think it's potentially a recipe for danger there. So something to be very aware of. It's kind of nice that they added it because it's a neat feature to have, but like I said, it's a bit of a path to danger.
Yeah, I never felt that like passing in a bunch of parameters was really that bad.
No, it wasn't, and it's I think good that you should have to think about it when you're writing that query. That what are the parameters into this query, as opposed to just trying to build up the string. So
it feels like the only saving grace around this is that at least it's only something that is exhibited when you're doing SQL.
Yes, so
and probably it's a very small number of people who are using Entity Framework that are going to drop to SQL.
Yeah.
And I still think it's like it's certainly some hidden properties of it there that unless you have watched this episode, like I would never have guessed this. So I think there's definitely some problems with that. Like it feels like, what's the principle that it substitutes? It feels like it breaks like the Liskov substitution principle in my mind, that you should be able to like replace that string with a subclass of string and the behavior doesn't change. And in this case, the behavior changes when we give it this formatable string, which is, I assume, a subclass of string or a subtype of string.
Yeah, that's something that I wasn't totally aware of, even the fact that formatable string was part of the equation here. And I was surprised that they were even able to implement that feature because I didn't know that formatable string existed. But there's kind of some funny behavior there. So I guess that was the other thing. If I were to just change this to a formatable string, so that it didn't do that implicit conversion to a string on the fly, that would just suddenly be parameterized again.
I'm trying to think of like compiler tricks that you could do, or like Roslyn analyzers that you could write to point this out, but it's really difficult to do because there are cases where you just want to run like SQL that is not a formatted string. Like you just want to run like select star from users or something, and like, there are legitimate cases for not needing to parameterize that string, so you wouldn't have a formatable string. I don't know, I would kind of lean towards changing that load to remove the one that just takes a string and only take a formatable string in that. And if you're in a scenario, like it's a very narrow set of scenarios where you want to use SQL anyway, and it's an even narrower set of circumstances where you'd want to use SQL without any parameters, that you could just set it up that like that is the behavior that's flagged, and we say, hey, look, like the default behavior is safe, but the consequence of that is that anytime you want to run non-parameterized SQL, you have to use a formatable string.
Or use the overload that just where you pass the parameters and the original way of doing it. But yeah, I would be tempted to use some kind of Roslyn analyzer if I was on a big team. And this kind of thing started showing up, I'd be pretty tempted to start failing the build if it on usage of this, just to be safe. Because the implications of getting it wrong are pretty serious if that SQL injection attack is there.
Have we done an episode on Roslyn analyzers? I feel like we did at one point.
I think we did, yeah.
If not, we should probably do one, because I'm starting to feel that Roslyn analyzers are super underused, and they provide the capability of enforcing, I don't know if there'd even be, you could say they're coding standards, but like best practices within your team that are not codified by the compiler, but are still things that you want to do.
Right.
Like I have an example that I'm in the midst of writing an analysis for right now that is, if you are using Mediator, my container has a mediator registered in it and has a logging mediator registered in it. So somebody writes a new controller that uses the mediator, the raw mediator, as opposed to the logging one, which writes out some log stuff. I'd like to throw an error or a warning there to let them know, hey, this isn't the right one to use. But I mean, I still legitimately need both of those in the container, but I want people to be aware, like, hey, don't use this one.
Right. Yeah, it's kind of a way to expose those rules that's in your face, and so hard to ignore, one thing, but also makes it more learnable for new developers because they see the error immediately or the warning. So good stuff. Yeah, looking forward to that episode, Simon.
Yeah, me too. Definitely gonna read that.
So that's all I had for today. We're gonna have, like I said, some more episodes kind of on this thread of new features. Most of them
so
won't
ASP.NET
have
and
security issues, potential security problems in them, but there is lots of new stuff that we're excited to dig into. So
great.
Be sure to follow.
Well, we will do that at some point soon. So thanks everybody for watching this episode of the ASP.NET Monsters, and we will see you all next time. Remember to like, comment, and share, and we read every comment, and if we read your comment on air and answer it, then we will send you a sticker, which I don't have any around
Looks
here.
like this.
Huzzah!
Yeah.
All right, so we'll see everybody next time.
Bye.